And we are now recording, and I got the recording started. Give it 3 seconds, and okay.
So good morning, everybody. We're going to start. There have been some issues with audio-visual. Hopefully that's resolved. What I'm going to talk about is how to exploit Android. Now, I'm not going to talk about all the ways of doing it. I'm going to talk about several specific things. But sort of from this specific case, we can see how many holes there are to sort of do more research on. If any of you remember Firesheep, this is a similar type of approach. Don't do it unless you get legal advice. Or you ask your mother, or if your mother is your lawyer, it's even better. Because Firesheep, you get to someone's Facebook account. Here we're crashing devices while people have stuff running. Unclear what will happen. Just a short introduction. Until 4 weeks ago, I was a developer, specifically a mobile developer. I'm now in application security. I've done some bug bounties. My employer requires a disclaimer that they're not endorsing this talk, and I'm here in personal capacity. My security involvement really has been around email security, so if any of you are familiar with domain keys, SPF, those are the things that I originally was involved with in 2003. There's some other standards work that's non-security related. RC 4180. Anybody who's ever seen a CSV parser, it's probably referenced in that particular document that I wrote, which happened incidentally, but I get emails all the time about parsing CSV files. Two parts to this talk. First, I'm going to talk about how you find the vulnerable devices. The second part is I'm going to go over some ways you can crash a device. Now, the goal, what I'm trying to do is, I don't care what device you're running, I don't care who you are. What I'm trying to figure out is, what is the security of your Android device? Specifically, what I want to know is what firmware is on the device, and then based on the firmware, that I can target known exploits against it. Specifically on the Android side, it's more, as many of us know, patching doesn't always happen because there's no centralized control. Unlike on iOS devices get patched faster. So one of the things that I would like to know when I start doing this research is how can we do this for Android? How do we have what patches there are? Another thing is I'm not installing apps on the phone. I want to do this passively, just by monitoring network traffic, kind of like Firesheep. If you happen to be on a local network like here, ARP spoofing, watching Ethernet frames, whichever way you want to do it, thinking of a router. If you take a step back, you're Verizon, you could see everything anyway. If you're a nation state, if you're a national security agency, if you're somebody like China, somebody like Russia, we're talking about countrywide scanning. And even though some of the things that I'm going to explain seem to be pretty simple, but the total picture that emerges, at least to me, was pretty crazy. So, I'm not doing anything unusual. I'm not going to start looking at TCP packets. I'm not going to start looking at NTP delays. All I'm doing is looking at user agents. For those of you that most of us should know, user agent is a string that identifies the software that is making the HTTP call. This is the code from RFC 7231, which is the most recent standard. It should contain information about the software. It should send a delivery request. What people do with that information is that they adjust the page depending on what's coming in. They're not supposed to do that. HTML5 standard actually tells people to try to guess the feature in JavaScript to detect that the feature is available now, but people do it anyway. Now, privacy. You're not supposed to include information in the user agent that identifies the person or the device. People do it anyway. Both the standard and Mozilla, this code is for the Firefox phone. They say do not put information in there, but guess what? Everybody does it anyway. And this is the part where I sort of want to talk about. Some example of user agents, you've got things ranging from browsers, all the ones on Mozilla. We have some that are very minimalistic, like for example, OpenHTTP is another library. It's got almost nothing. Curl, Perl, those libraries are very, very minimalistic. As you can see, the examples here, specifically Nexus, the iOS strings, the Windows Phone, there's extra stuff in those requests, and that's really what I want to talk about. Main question is, so user agents have been around forever. Am I really going to be able to figure out that a particular device is vulnerable just by looking at the user agent? The answer is yes. And this is also true for desktop computers, and you don't have to trust me to that. You got the NSA telling you that. These quotes are from the NSA slides on user agents. They were taken by the Snowden, and they're published by the Intercept. In NSA speak, user agents can help identify CNE, computer exploitation, aka hacking malware. They don't actually tell you how to do it, but it's definitely they are aware of it. Again, this is 2010. If you give you the phone model, then you correlate it with the IER, which is the identifier for the phone itself. Now, this is all sort of general. Digging into the Android piece specifically. So what this is an Android user agent. Now, there are three things here that a normal user agent doesn't have. The three things, and this is helpfully highlighted by Google itself. You got the Android platform version number, so this is pretty good. If you got Android 4 or Android 3 or got Android 2, if they are known to be unpatched, you can make a general estimate of, let's say Android 4 has these particular vulnerabilities, then you can try getting it. The problem is you don't actually know what the user is running exactly. Custom ROMs are not part of this because custom ROMs have their own way of doing user agents. I'm just talking about things that are off the shelf. The device, that's the next piece. So the user agent will tell you what the device is. That's not really helpful because yes, if you got a Galaxy Note 7 that tends to blow up and you have a way to get the battery remotely and blow it up, yes, that's very helpful. A lot of devices that are more generic, like the Nexus one, all of the Android devices that Google makes, it's pretty generic. The third piece of information, and that's the piece I'm going to focus on, is the build. The build is sort of something that we probably have seen all the time. Build will map one-to-one to what the firmware is. If you have the build number, you know exactly what branch it was built from. You know what exact version of Android is in there, and you also know what vulnerabilities this thing has and doesn't have. And there are a couple of things that the user agents by themselves seem pretty harmless, but if you start sort of adding to the picture, then things get pretty interesting. So these are the different examples of user agents on Android. So you got the Chrome web browser, that's the first one, and that's the one that basically just says Mozilla on it. You also got the web view. The web view varies slightly between Android 5 past Android 5. If you have an Android application that wants to have web browsing inside, they use a web view, they embed Chrome into their application. And those are the next two. And then you got the last one, the second last one, that is the HTTP client. That was used by everybody. You got running an app on Android, unless you do something different, that's the agent you get. The last two are things that are more unusual. If you're using any of those two libraries, that's what you get. You either get a user agent that has no information, or you get OKHTTP. And now, just sort of a side point, these are not set in stone, they're changeable. At least when you develop an application, there are limits to that. So, if you have an Android device, these are the strings you look for. You're looking for either the browser web, or they do something on the application layer. Obviously, the last two are pretty useless to us, but there's plenty of fire from the first ones. Now, the build itself, what is it build number? The image in the bottom is taken from the attribute compatibility definition. It's just an arbitrary number, letter, identifier. But what it does is, when you have a ROM build, it's got a unique build. at least within the official Google Android space or Google non-Google phones. Once you go outside of that space, you do custom routes, you do Cyanogen routes, that doesn't necessarily apply, although for Cyanogen routes, they're also probably pretty standard. Now, if you have the build number, if you work in software, essentially it's equivalent to a software build. You package everything together, you push it out. That's what this Android build is. Google doesn't actually tell people, how to use it, they just say you have to use it. Now, here's the problem, and this is really the core of the problem with Android. For those of us who've used desktop devices, you got Windows, you got Linux, you got many patches that come in. Yes, micro-certification bundles on patches cumulative. Most of the time, you got individual patches for individual pieces of software. If you got a typical Linux box and a Linux box sitting next to it, they could be very different in terms of what patches they're applied. You take two Windows boxes, let's say they're both running Windows 10. Most of the time they probably will match, but a lot of times people will want out, or a particular patch won't apply, and they are basically very granular. Now the problem with mobile, and this applies also to devices like the Chromebook here, there is no modularity. If you want to update something, you got to do a new build. But what happens is, Google and particularly other vendors, every time there's a security patch, they do a new build, give a new identifier. So what happens is that it's very easy to see, you got say 10 builds, this one has this one doesn't have it, this one has it, this one doesn't have it. It becomes pretty simple because they're very monolithic. The other problem also here is that, and I'm going to get to that later on, the fact that they're monolithic is a symptom, it's not the actual cause. The cause is that in Windows and Linux, you got the kernel and user space, they're separated. In Android and to some extent other mobile operating systems, a lot of what we call user space stuff tends to go into the kernel level, and they kind of like get mixed matched and they get packaged together, and that leads to some interesting attacks. And I'm going to discuss later. So this is really the core. You have a build number, you figure out where it is, but you have to have the information about it. So I looked around, I have not been able to locate a single database that contains every single build number and every single image that corresponds to it. But if you have the image, you can extract the build number automatically and the date when it was built and which branch it was built from, because those property files are packaged in the ROM. So for someone to go ahead and build a piece of software that does this, it's pretty simple. There's an extra bonus here. Google has a predictable scheme. Now, that means it's somewhat complex, but you could make it into an algorithm. Based on this algorithm and looking at any build for any Google phone, you could figure out what patch level it is, just based on the core. Because, for example, patch level October 2016 would be a different day number than, let's say, November 2016. So for Google specifically, that means that you don't necessarily need a database. You could just basically work it out. And now you have sort of the Android bulletin for a particular date. You have the builds that correspond to that date, and the CD numbers, and you can kind of draw the conclusion from there. You write a parser, does it radically, and then you've got yourself an instant way to know which Nexus device is vulnerable to which CD. Here's some examples. These are mechanisms, just random mechanisms I pulled off. The dates come when I was able to get it from the ROM image. So you got your Galaxy Nexus version 4.04. It's obviously vulnerable. You got your Nexus 5, which obeys the scheme we just discussed. You got your Sony Xperia. You got also some more unusual ones. Android 6.0 third developer preview. Blue Life. There was an exploit that came out 3 weeks ago that learned that blue phones have been called, ET called home to China. You want to find them? That's the way to do it. Last one is the Galaxy Note 7. Now, I don't know for a fact if an exploit exists like that, but if somebody has a way to blow them up, that's the way to find them. And the build is also very carrier to carrier sometimes. So, for example, if you want to find the Galaxy Note 7 that's AT&T specific, if there is a specific build for it, find it. But we don't really care in terms of particular devices, because majority of vulnerabilities are software-based. So as long as you define the firmware, you don't really care what hardware underlies it, unless that particular exploit is hardware limited. Here are things that make it really bad. Your phones, if you have Android, are right now sending data, and you don't know what it's sending it to. Why does that happen? So Android apps and OS will send data all the time. The example I'm going to give later of an exploit is that Android OS sends data as soon as you connect to the network. Other apps do that as well. There's no user interaction, and it will continue sending the data on its own. Most apps will use the default Android library. That means that user agent we discussed earlier, the Dalvik user agent, will be sent all the time. Data is not encrypted in Android because it's not mandated by the platform. For those of you who are iOS developers, know that January 1st, all iOS applications must have SSL, no exceptions. But this year, you put exceptions in. As of beginning of next year, no exceptions anymore. The last one is really what is sort of the cause of the first, or if you're building an Android application, your apps has apps that has apps that has apps. Because what happens is you are adding, let's say, Crash Analytics or Crash Manager. You're going to have Mixpanel for handling analytics, Google Analytics. And then those use other libraries and those use other libraries. I'm going to give an example in a minute of something that's supposed to be secure and encrypted, but here it's doing calls that are unencrypted because it's using a library under the hood. And one of the reasons for this is because Windows development, like 10, 15 years, there was no cloud paradigm. You got to buy a library, you stick into your software, you got to run your own server. A lot of these services now come with cloud-based servers, SaaS applications. That's one reason. Another reason is that there's a lot of open source now more than there was ever before. So people tend to put things in, but they don't realize what those things do. And what happens is, as a result of this, most Android apps are sending data in unencrypted form to someone. In the process, the user agent gets sent. So I would say that, at least in my testing, an average, I have not yet seen an Android phone that doesn't send any data unless it doesn't have any apps at all. But even the OS itself sends data as well. So in 2005, 2006, there used to be, I think, Zolar, used to be a firewall for your PC. There isn't one for Android that's on the shelf, that Google provides. I'm sure they exist, but that's kind of almost what you need. Also,
You think that iOS is mandate SSL, does that mean that all iOS applications will be forced to use SSL in all communications?
That's what the game plan is, but this is Apple. That's what they claim. I don't know what's actually going to happen.
It sounds very unlikely. They can't force absolutely all communications to use SSL.
But this year already, if you're building an iOS application right now and you're not using SSL, you have to have an exception to your manifest. You have to do it today. That's true today. So they're already halfway there. But again, I haven't done a lot of research on the iOS side, so I don't know for sure. There's some on the Android side, something similar was in the works. One word about SSL: just because you're using SSL doesn't mean you're using SSL. Apps that I've seen that do any kind of, basically if you go off the default stack, if you're doing gaming, if you're doing video, think of something like Skype, Netflix, they reinvent SSL, and I've seen apps do SSL with some, those SSL certificates. CertCC has done, I think last year, a study, like an automated study. They found like 200,000 applications that don't use SSL correctly. So that's also another hurdle. Now, here's an example. This is WhatsApp. Now, WhatsApp is supposed to be super secure, super encrypted. First thing WhatsApp does is call Google. My suspicion is, without knowing what's in there, is this particular URL for Google is used to check connectivity. But if you notice, the second line is the user agent. That is the Nexus 6 build as of November 2016. And this happens on every new network. Here's an example of an IoT control app. The bug has not been disclosed yet, so I can't tell you which app it is, but it controls things like lights and some things in the house. It's called Mixpanel. The distinct ID which I blanked out is an email address that's used to log into the application. And again, they may be using security. They added Mixpanel. They didn't realize Mixpanel is doing an unencrypted call. Now I know what device they're running. Adobe Air. This is a bug I reported to Adobe, which I found by accident. You build something in Adobe Air, it calls Adobe without encryption all the time. Don't know why it's doing it or what it's doing it. They're claiming it's runtime analytics. I don't know what that means. But they're doing it. They just fixed it. This is Android OS itself. Every single Android phone will do the stall on a new network. And this is a bug I'm going to get to in my second part of the stall. It happens by itself. You can't lock it. You can't disable it. Some things that you could do. Android apps can't override user agents. Firefox does that because they want you to be more private. iOS has the same vulnerability in theory. There's a website out there. You could correlate the build numbers in the CF network against builds in iOS. But again, I don't know how much you can actually do with that because iOS devices are updated all the time. I found a bug with Google to get this information out of the user agent, and Google said no. Problem for Android, if you do a desktop page, if you do request desktop, no leak. Why? Because it masquerades itself as a Linux user agent with no build number. Why? I don't know. But those are sort of random things that I've seen overall. Research is needed on this particular area, and also kind of stepping back for a second. Android's app leak data all the time. This is one example what you can do with that data, but there are many, many more. I mean, there are so many things that go out of an Android device that this is just, I wouldn't be surprised, many more examples like this. So, bottom line here is, what I have found to be true is that most Android devices leak the user agent. Most user agents have the build number. Build number will give you the vulnerabilities. And that's the second part that I'm going to talk about. So the question is, okay, you got the firmware, what do you do? You got the firmware. So here's one example. This is stagefright. This is a screenshot from exploit.db. If you look on the right side, those are build numbers. I didn't actually try this, but it would be trivial. Now, the reason why I picked stagefright specifically is because the attack is remote to the browser. You find the device, catch its Chrome traffic, stick an exploit in, you're done. I haven't tried this because my level of expertise does not extend to that level. But I will show you 3 things that I did try, which ended up crashing in front of me. Now, if you're like me and you can't write binary exploits, what are you going to do? These are 3 CVEs that crash Android phones. The first one, 6723, is pretty hard to pull off. It was fixed in November. The second one, 5348, is the one I was referencing earlier about GPS. Third one is not a direct one, it's unpatched. Now, I do have permission from both Qualcomm and Google to discuss 5341. The patches to Qualcomm came out in September. Google's putting Android patches on Monday. I don't know what's in the patch, but they're claiming that they're putting the patches out. The first one, now again, I'm not trying to inject malware because I don't actually know how to do that yet. But here's what you could do. This is pretty complicated because you've got to be running in an environment that is a proxy file. The PSC file is a proxy file. If you are using it, someone catches it, there's no magic here. You basically just create a large packet, send it back, phone will crash. Now, there's something called WPAD, which Android thank God doesn't support. WPAD would auto-configure the proxy file. So if you have WPAD turned on, then as soon as you connect to the network, we'll configure the proxy and crash it. This doesn't happen today, but they're talking about it. One last thing, path files are not text, they're code. Question is, what's parsing that code, and is that what is vulnerable? So that's something else to look at. Here's the configuration for Android. Here's the actual proxy file. As you can see, it's JavaScript. To give you sort of a sense of time, this thing is from Netscape. It's like 1994. That's how old this is. The standard really hasn't changed. It's in use today, but it's very hard to pull off because you got to find a user and a network that's actually using it. You got to entice them to put the configuration in, or install an app that does that. So pretty hard to pull off, but this is why it's happening. And this is where I started digging. This is an OS level process that pulls the file. If you notice the last line, streams that read fully, That is a code in Android that will completely define all the network without checking its level. You got 1 gigabyte working memory on Android, you read a 2 gigabyte file, it crashes. There's no check. Several problems. Why is this in OS level? Why isn't this user space? Why aren't you checking the length? And the answer seems to be is that one is user space, kernel space, there's a lot of crossover in Android. Second thing is we trust the network. And that's sort of what this bug is all about. The next one is way more interesting. This is the one that I showed you earlier. This dates back to 2007. You found that a GPS chip from Qualcomm, it's getting that file. Why is it doing that? And people have spoken on the Android side, they've seen this file, there are forums full of it, oh, my GPS is not working, configure this setting, and it starts working. Now, the way GPS resolution works is you gotta find the satellites, that can take up to 2 hours. So Qualcomm came up with a shortcut. We'll give you the almanac data. The almanac data is where each satellite will be in the next 7 days. You get it on the internet, and then you can cache the satellites. So it's pretty innocuous. Same exact bug. You get a file large enough, phone crashes. If you don't, like in my experiments, if you have a network, you tune this thing on, you want to keep it in file, phone crashes and crashes and crashes and crashes. So if you don't want someone in your network, that's one way of getting rid of them, just keep crashing phone. Now, here's the scary part. This is Qualcomm's guidance from their booklet about how this works. On the bottom, you'll see what's actually happening. Qualcomm serves the file, it goes with the Java code, that's where the crash happened. Then it gets filled with the GNI code, which is C++ and Android. Then it goes into the modem. This thing hits the modem directly. Now, I can't think of too many vulnerabilities that allow network access to the Qualcomm modem without any user interaction, but this is one of them. Happens by itself, nothing good to stop it, although I haven't tried disable location services. This is not an Android bug specifically, although this CVE was assigned to Android. This is the example of the file itself. It's called extra2bin. If you can see on the bottom, it's coming from CloudFront, and this is why it's happening. It's happening because, same thing, nobody's checking the response of how big the file is supposed to be. It affects every single device that's got a Qualcomm chip. They've been doing this since 2007. I've only been able to crash Android. Microsoft and Apple claim that their device is not affected. BlackBerry is affected if it's using the Android code, not I don't know about the other non-Android Blackberries. Now, this is a little more scary, but it's also OS level. I managed to crash it on the Java side, which is the top. Now, it is possible to crash it lower, which is possible in Android, and also, theoretically, if it goes into the modem, bad things can happen. I haven't tried that, but I don't have the expertise for that. Now, here's the interesting thing. This was patched in October. Now, if we sort of go back here, there's a missing piece here. Why does this happen? And one of the reasons why this happens, if you look at the call, this is an unencrypted call, there's no sound. This is 2016-5341. Qualcomm has been serving these files without checksums and without SSL since 2007. In 2014, they have found out, or somebody reported that this is a problem. They've been fixing it since 2014. Android patches for this will come out on Monday. Again, this is a screenshot of what's happening. This is what their fix is. And again, I haven't seen the patch, don't know what it is. The files include almanac data for GPS, but now they added GLONASS Galileo. There's no SSL. So one fix is they're going to add SSL. Second fix, they're currently delivering the 2 files on top. One is a binary file that has no checksum. The second one is a simple checksum, which is trivial to figure backward. Extra3bin is supposed to be the new super duper digitally signed file. So their fix is allow SSL, which considering they're on CloudFront, is trivial, and also digitally sign the file. I don't know what the guidance to their OEMs has been, because it's proprietary. I would hope that the guidance is that the digital signature should be checked before the file gets injected into the modem. But I don't know. I really don't know what happens once that injection happens in the modem, where the verification happens at that level. This bug, Qualcomm has told their OEMs about it in September. Google doing an Android patch on Monday. But this is not currently exploitable because the previous bug that I showed, 5348, was essentially exploiting this. I haven't tested other devices, but I talked about a couple of billion devices, GPS chips. What I was really hoping here is that you could mess up a GPS, get wrong readings, and when the drone, the radians called the drone in midair. But I wasn't able to do that. Qualcomm claims it's not possible to change the GPS readings by changing this file. I don't know. Two more things here. Another third thing. This affects the desktop. So, what this is, AutoComplete. AutoComplete in the browser, Firefox, Chrome, IE. It also works on Android. I went and looked for this stream read fully. I found it in the Android browser for Android 4. It will crash, same way, no check. But the crucial difference is it's crashing on the user space level. So the browser crashes, and Google said they're not fixing it because it's not an OS level crash. It also affects desktop browsers. It will crash your Firefox browser. If you're using Ubuntu, it will freeze it. It will crash Chrome under certain circumstances. Now, the underlying core to this is that one of the top 5 search engines in the United States is AOL. So if you happen to switch to AOL that's not using SSL, that's what happens. So I would say who cares, because who's using AOL? But the search engine listings in the browsers and Android vary from country to country. Some countries, most search engines don't use SSL. Again, same exact impact, do not trust the network. In the case of Firefox, one of the most scary things is that it's not actually a separate process, it's using XML HTTP request, lower level. So I haven't followed that through, but it's also kind of interesting. And this is sort of the last thing that I want to talk about. What I discussed is crashing phones, right? It's okay, you crash a phone. These are some of the examples of what apps are doing. So for example, the second example is I've seen this in App, which the bug has not been disclosed, I can't tell you which app. It does an update check. New version is released, it will tell the user. Block it, they'll never hear about it. Yes, they'll go into Google Play eventually an update, but till then they'll never hear about it. I've seen a shopping app that injects images and videos through non-SSL, the rest of the app is SSL. You can inject your stuff in, and then make it go somewhere else. If you return a mail from a very large packet, you crash a specific app. The same way that I was able to crash the browser or the OS, but in the user space. So for example, if you're a carrier that doesn't want people to use a particular app, and that app is unlucky enough to be doing some sort of a check like that, without user interaction, that's your way of doing it. WhatsApp. What the original URL is a connection check. I haven't tried it, but if it's a connection check and you mess with it, WhatsApp within your offline, and then the sort of the secure transaction will happen. Don't know. Something to look at, but bottom line is, like what I said all in the beginning, is that you can't trust the network, and you got to be using SSL. And some of the things you could do, so the user agent, this is the last slide, user agent specifically. If you are an app developer, you can change it. You could, on Android, you can change it. iOS, not so easy. Use SSL. Use SSL correctly. Don't roll your own encryption, don't roll your own SSL. Protect users' privacy, sort of a general thing, is if you never did an audit on your application, you don't know what it's doing, what it's sending. I mean, the application, the app that I'm using is an AppVM proxy that runs on Android. I just turn around and just see what's happening. It's called packet capture. It's trivial to try. If you haven't done that on your app, you don't really care about the users then. And you can't trust the network. The examples I gave earlier, you can't trust the network ever. And be cognizant of the things you're putting into your app. You have an app that's got 10 other services. You're secure using SSL, you're doing everything, what is your, the panels of the world are doing? What APIs are they doing? For some of us application security like me, we do component checks, and often, like I said, components, and we find all kinds of stuff. If you are someone like Google, forcing app developers to use SSL, perhaps not as drastic as Apple wants to, but with an opt-out, maybe lead developers towards SSL, encourage it. Don't need data about user devices. The build number is not needed. It's an example. You don't need them. Why do you have it in there? And don't trust the network. Same thing, you read stuff to the network. If it's a GPS file, there are other examples in Google retrieves SMS blacklists. Why are you doing it without SSL? OCSP checks are done without SSL. There's actually a way to crash the open SSL, the way to do the DOS attack. Something similar happens in Android and iOS. I haven't tried it. Those are the kind of things that people should be looking at. And again, everything on this panel is very simple. There's no binary exploits here. It's just very simple capturing traffic, injecting traffic, crashing. But these are the things that I found and that I want to share. Did we have questions? Yeah.
You potentially use this as like an overflow attack?
Essentially, it's an overflow, yeah. But it's not a class of buffer overflow. It's more like just a large file.
Memory exhaustion?
The what?
Memory exhaustion?
Yes. It's a very simple attack. It's not, it's just exhaustion of the overall Android memory. I'm not trying to figure out where the buffer overflow and stick something into memory. Phone reboots. So that's what I'm saying. It's very simple.
What's your personal favorite user agent plugin?
There is no user agent plugin. That's the problem. Firefox.
Browsers.
Firefox. That's the one that we use for Android.
So what plugin?
Android by default will not. So Firefox, I haven't checked the latest version, but the one that I checked 2 versions ago, by default will not have the build. You could use it also, but I think Tor has a version for Android also.
Would you say that at this point, any kind of non-encrypted communication on HTTP is subject to this memory exhaustion thing? I mean, looking at traffic in so many types of devices, end-to-end encryption is just not feasible. It's just not going to happen at times. So there are so many ad networks, there's so many things that are implemented in WAP. I don't think there's even your Chromebook over there is going to have a few things that are
right. So the patch that Google put in for the GPS log and the packet log is that they're going to check the length of the packet. And as the HTTP traffic is going through, they will cut off at a certain point and not accept anymore. Those are the kind of checks that will happen. Meaning, if the default network and library in Android had capacity to automatically check for that would be very helpful, even without SSL. I mean, there's a way to do this. Part of the problem here, Android re-implemented Java. So streams that read fully is not something you find in regular Java and in JVM.
I think that the bug should be solved at the parser level, like all the things, validating input and all that stuff, rather than you manage to use SSL everywhere.
That's possible.
It's nice. It's nice.
Right.
I would love to have SSL everywhere, but I just don't see that.
Right. So that's if you're not using. So I mean, there's the theoretical nice thing to have. Yes, SSL is really nice to have. If you can't do SSL, then you got to be really careful about what you're accepting. And what I have seen in most apps and most open source, they don't necessarily think about it because like who's thinking about data being intercepted and then again we're not even manipulating data. We're just putting a lot of problem. It's just kind of thinking about it. Another thing is also they may be putting a check in the program, but Mixpanel might not, or Crashlytics might not. Whatever API library they're using might not be doing that. So when you're using something, you gotta be comfortable with what the API or the library you're using that's going to be. Any other questions?
When you submitted the bug to Google about the user agent, when they rejected it, did they give you any feedback or just outright rejected it?
What's the abbreviation that works as intended? WAI? Something like that. I mean, don't get me wrong, Google's really great on the other bugs that I did, but this particular one is really sad. Anybody else?
I'm curious what work you've done to try and enumerate all the possible user agent build.
So I haven't done that much. I mean, on the Google side, I went through the images that they have, the firmware images, and this kind of gives you a shortcut, this algorithm. I just went around and basically looked at the builds. So if the build was available from someone like Google, I downloaded it. I also looked on XD developers. What I'm looking for is the stop round, not the modified one, because I don't see the stop round. You open it up, it's what's it called, build a prop file or something like that. Just check data straight out there. But again, I didn't have to do this as exhaustively as I wanted to, because I don't have the time, but it's not that complicated to do that. Another question. Thank you for having me, and enjoy the conference.